Hello, dear friends. Oh, very high sound. Okay. We continue our conference. Today is the second day, and I would like to invite on the scene director of Югры Research Institute, Андрей Мельников, application of deep machine learning models for processing satellite imagery to solve practical environmental protection tasks in northern territories.
Good morning, dear colleagues. First of all, in my report, I want to talk a little bit about Югры Research Institute. Oh, sorry, presentation. This is the plan of my report. First of all, about Югры Research Institute. Very interesting institute was established in 2001, so more than 20 years, by local government of Ханты-Мансийского region to solve the practical tasks of use information technologies for some different questions. Of course, first of all, to optimization of government. Now it's more than 100 high-skilled professionals in 8 IT centers. Our main activities is space service, software production, IE application, information security, IT for gas and oil industry, and also education IT activities. Last year's use of approaches of artificial intelligence, different kinds, or deep learning models, maybe for these more clear terms, become as one of the main direction of invest IT technologies in different kinds of areas. I will talk only on few projects before I will start talking about environment protection. One of our projects now is Intelligence Service Infosphere. It grows from near assistant that it was used for government or regional government. Our main ideas is that we use chatbot, but chatbot based on two main points. One point, we use local models. Now we, on our locally, we use the best LLM models, for example, DeepSeek RD, also only quantized, not enough resources. And also the second one is knowledge domains. What this means? This means that for every task, we prepare the database or knowledge base, especially prepared for use for LLM to make in RAG models. Also, we use a specific role of every person who works with this model. For example, the role of officer of government, the role of teacher, and so on. Now about 3-5 roles is implemented. As a result, this is the interface of such system. Now it's on the stage of practical use for government, regional government, and also it's used for several oil companies for tasks, for example, teaching in new information systems. I need to say that one of main sphere of use such system is preparing protocols of meetings in the government. Now it's working in practice use. Another interesting project that we also now continue to design is Mathai language corpus. Low amount of corpus for people who live in the north is a problem. So we try to solve this preparing special corpus of Mansi language. Now it's more than 1,080,000 pairs of parallel sentences, due to which we now have online interpreter working really, Mansi Russian dictionary, and so on. Now, in our task that we are solving is Mansi LLM task. To, for example, tasks for generation some stories for Mansi for retail, Mansi SST, TTS, and Mansi ONCR. So to make real environment, to support and to make a model that live for further of Mansi language. Also, future our project will be Hanты language also. Now I want to return to space theme. Now I need to say that in our institute works the Space Service Center. It was established in 2012. Now it's work closely serving the organization, regional organization. So there, for example, one only digit, 1.5 billion rubles calculated damage based on space data annually. So we make monitoring of space monitoring all territory of Ханты-Мансийского region. I need to say that Ханты-Мансийского region is rather big. Its square area is about the French. So there is a problem of how to monitoring it for any damage. What task we solve? Sorry. First, oil spills, because our region is oil production region, and mining, first of all, mean tubes on which oil is pumped. So this is a problem of our region. Secondary, land use. Next one, dump monitoring. Next one, monitoring of land squatting. But I need to say that these all projects still now working in typically by hand variant. This means that we can't use effectively some models of machine learning. The main reason is bad data sets. I need to say that in our region is very usual frogs and cloudy. So due to this, we have a serious problem to receive a good space sheets. So one of our interesting project, Yugra forest control. The idea was to monitor the territory of Ханты-Мансийский region to control landing or in the forest, and also in its violations. For this, we now use the space images from Sentinel-2 satellite images that is divided in 7 tiles cover Yugra territory. I need to underline that typically we receive 30 tiles every day. This mean tiles is 110 kilometers to 110 kilometers. And the processing 2 tiles per day is possible by hands. This means that we need at least 50 people that every day need to monitor the territory of our region. So it was decision to make some approach based on deep learning. So we prepared data set that was divided to winter model and summer model. Why so? It's due to images is quite different in summer and winter. So we decided to divide it. And also very important, we use multi-channel information that can help us even find landing due to cloudy. We investigate three approaches: traditional methods, convolutional neural networks, and transformer networks. Of course, it's clear that transformer neural networks now is most, how to say, powerful approach to segmentation, but I need to say that in our situation, when the data was not so good and not so lot, the best results we receive on convolutional networks. So our base approach use multispectral, introduce division by season, and also very important, apply to multi-temporal series approach. This means that we use two images before landing, after landing, and every time compare it. Very important thing that show the importance of good data. Look, for more than 10 years, we collect data that was hand marked. This means by people. But when we use this data, when we learn for neural network, we receive only result was UCF score 0.778. This wasn't useful in practice. Too lot of fault information. So what we need to do? We need to hand check all for images. This means 50,000 images, for example, for winter. Hand check to prepare the good data. After that, we immediately receive much more better results. Also, we use several, how to say, tricky games. This is, for my opinion, now a typical approach. Then when you need to solve a practical task, it's important to use only one model and simply have data set, you prepare network, and then no. It's only when you make some approaches, additional approaches, for example, like here is mosaic augmentation. So these improve the results, for example, 1.6%. Not so big, but very important for practice use. As a result, now our best result, for example, for summertime is 91%, or F 0.91 for this. When we implement this model to the practice, we increase productivity 16 times. Also, possibility to monitor an area expand 10 times, and very interesting, reduce number of lodging missed by specialists. This means when specialists look to the image, 50%. This is a system that's now working in our institute. So we receive images, prepare it, decode, then work with neural network, and afterwards put to digital map display. Very important for practice use, you know, that a lot of models and tasks now in artificial intelligence still stay in R&D stage. This means project is yes, but when we start invest in real practice, we meet a problem that people don't need it. For example, one of my projects was when we classificate the incoming calls of to calling center of region. As a result, we make it model working good, but the real people that receive calls, they say no, we know what we need, so we don't use it. So in this situation, we integrated to semi-automatic process of forest lodging monitoring. What is important? This means that the results of working neural network result in official letter to special, for example, police to control situation, and afterwards the Department of Nature Care controls the situation, and afterwards we receive such result. Look, after using this model, violation number fall down more than 90%. And very important that we are proud of this, more about 4 times, or 4, let me see, 6, maybe 6 times, illegal timber extraction in our region. And now in our region know that if you start cutting the forest landing, so immediately you will have a problem serious. In any case, especially it's a big amount. Our approach in 1993 was the meeting best, one of the best in our Russia for nature care. Not only how to say practice task we solve with approaches of artificial intelligence. Another task that we are solving is calculating or checking how natural indicators of global climate change can be how to say investigated by space images. We look what categories of indicators we can use in northern regions. This means change of ecosystems, for example, type of forest, shift of natural areas, for example, boundary between forest and tundra, changes in vegetation species composition, permafrost, of course, very important, hydrologic regime of water bodies. But we choose another position. This is ice regime as indicator of climatic change. So when we work with space images, it's very easy for us to collect space images for 4 regions. We, how to say, we use 4 regions from south to north that can be representative in climate change. We use data from several sources that show us the change of temperature in this region. This means in the central point of change of this region. Secondary, we determine how on MODIS we check several space images, and the best was MODIS images. We define how on MODIS images we can define the time of ice appear and ice go out from the lake. And it was the best result was we compare it to the Satlan Gaijin station that really check the ice on the lake. So the best result was when 12% of surface is open water. So this most accurate data. So after this we determine the average ice threshold value for satellite data for every zone. This means rather big amounts of lakes, so it can be, how to say, average data that we receive on this. At the first stage, I need to say that this is only preliminary investigation. We done linear only approximation, and the result very interesting. You remember the zone 1 is the most north, 4 is the most south. And what changed? The speed of change of this ice threshold. Look, in the north we have more than 3 times more faster changes. It's very important, especially for our region, because the main construction for roads, maybe oil stations, and also oil mining stations is winter, because in summer it's impossible to construct anything. our region. And now you see, in 20 years, we have a serious change time of ice threshold in this. We intended to continue this, and main results of investigation of ice duration is a major indicator of climate change. Ice duration in remote situation for several images, space images, we developed, and there we use it's very simple machine learning neural network models. Spatial elevation ice residue education was revealed, so we see, and also very interesting, strong correlation with air temperature. We also compare it, for example, with another parameters, for example, solar intensity and so on. But this is now is the main influence on this. And the results confirm more intense warning in north regions. Finishing my report, I want to say that our institute is very practical. We can't make academic investigation, only little bit maybe by grants. And looking now how quickly develop the approaches of artificial intelligence and trying to invest in different areas of activities, for example, government, oil companies, so on, we see that now it's still not, a real practice useful. This means, yes, sometimes it's model very good, yes, no, only several projects finished with a real practice, like resulted like I show in my speech. And second one, yesterday, several very interesting reports that discuss that problem of hallucination, problem of mistake of neural networks. My opinion, still the use of approaches of artificial intelligence to solving practice task still is some kind of engineer or tricky game that is not can't be good described in good mathematics. Thank you.
Okay. Миша, дай мне второй микрофон. Включи, пожалуйста, вот этот. Thank you, Андрей Витальевич.
Okay, thank you for good report. It's very fulfillment, very applicable approaches. First of all, I want to notice we have to discuss about maybe collaboration, because our AI center in Novosibirsk State University developed a smart cities application. Maybe your application we can integrate in smart cities, because in city we can also analyze some areas where ice, where maybe snow on the roofs, or etc., and we can employ this in this direction, and maybe we find some time after conference to discuss about this, because I see it's very important area for understanding, for management of all process in the city. Yeah.
Thank you, Andrei. I need to say that our institute is center of digital transformation of the region, and task, for example, of digital city is quite near to our task. So it will be wonderful, and I need to say to all my colleagues, I am fully open for cooperation. We cooperate, for example, now we visit MOM. We cooperate with several partners in Moscow, in St. Petersburg, in Irkutsk. So we are ready to cooperate, because it's very interesting. To use the best approaches to solve a practical task.
Moreover, I see opportunities in China-Russian collaboration because, for example, in CI and PU, they developed aerospace devices. It's aircrafts and rockets and other. And I think also will be important analyze weather and other clouds and etc. For starting, for example, and down aircrafts and other complex devices. Yes,
very important, good idea. I need to say that now we discuss with several our partners from China about joint projects.
Yeah. Very interesting. Thank you very much.
Не, нельзя, человек уже выступил.
Сергей Севастьянович, please.
Вопрос такой. Раньше был Ханты-Мансийский, вот у нас же институты очень много. И были заказы именно от компаний, которые, газовые компании, нефтяные компании, вот у этого центра. А вот как сейчас стоят эти контракты и...
I need to say that we have sent of oil and gas companies, that IT technologies. But how to say, for example, Gazprom Neft, you know that they have a very big center of artificial intelligence in St. Petersburg. So at the moment then we offer for them some projects, no, it's impossible because local branch companies of Gazprom Neft, they don't have possibilities to have direct relations, so on. So we work in different way. For example, now one of the projects with Surgutneftegas is preparing education materials on information systems for import change, for example.
Ну, вот компания Саши Жижина, там очень активно работает, а вот, так сказать, свои локальные...
Да, ну если переходя на русский язык, локальные дочерние компании не имеют возможности заключать локальные местные договора, а у них как бы сейчас это жестко запрещено. Поэтому все контракты, которые, например, заключал, это смешно, это было, например, Москва, Санкт-Петербург и так далее.
Okay, I also can see some improvement. I see. Sorry. Okay, Alexey Lvovich, I did not see. Okay, start. Please.
I think it was really fantastic work. It's extremely interesting, and I think really with cooperation with other agents, we should use the position of Madame Komarova now and just to have a something listening.
Now Madame Komarova is changed by Kukharuk.
No, I mean he's in the Soviet Federation in the upper house of the parliament, and she's in the committee for also
nature protection.
Nature protection. Yeah. So she should have a listening in the parliament. In both chambers of the parliament on this. And one specific question: from whom you are buying the images, and what is the resolution?
This is European Sentinel-2, European.
Yeah, so directly from European, yeah?
Yeah, from the European, but we not buy.
Not through the
it's free of charge. Only
so it's 5 meters. So what is the
yes, perfectly.
If it's
and
smaller,
also
you should buy
multispectral, very important.
And multispectral.
Multispectral.
Infrared. And
And infrared. Because we use, for example, not 20 channels, for example, 12 channels.
But it's 5 meters and it's open. Okay, thank you.
Yes.
Thank you very much for questions. Please come in. I have.
Я прорегистрировался. Александр Югорских, университет ЭТМО. Позвольте пару технических вопросов как раз по проекту распознавания леса. Во-первых, по трансформерам. Как вы тенсор формировали? 12 спектров шли как каждое измерение тенсора?
Мы их комбинировали. Более детально сегодня в 14:20 будет доклад моего партнера, который расскажет более детально, конкретно вот эту модель.
Хорошо, тогда вопрос короткий. Помимо секформера, что еще? Потому что секформер достаточно старенькая модель.
Ну, мы ее в прошлом году как бы закончили, попробовали, и сейчас работаем все-таки на этих конволюшенах.
На юнитах.
Да, юнит.
Плюс. Еще готов побеседовать с вами на эту тему.
Хорошо,
Это
очень интересно.
Thank you, thank you. Maybe someone have a additional last question? No? Okay, additional congrats for report. Thank you, Андрей Витальевич.